Hey there, welcome back to our channel, where we uncover the secrets of the nature. Today, we have an intriguing question that, do the Pacific and Atlantic Oceans mix? Well, get ready to be amazed because we have the answer for you. So, let's get started. Are the Pacific and Atlantic Oceans truly separate entities, never mixing with each other? This question has sparked curiosity and even led to viral videos on social media showcasing distinct boundaries between the two bodies of water. In this video, we will explore the reality behind this claim and uncover the truth about the interaction between the Pacific and Atlantic Oceans. The vastness of our oceans often leaves us mesmerized, and it's natural to wonder whether they truly intermingle. The claim that the Pacific and Atlantic Oceans don't mix has gained attention in recent years, fueled by videos depicting stark color boundaries. Let's dive deeper and uncover the science behind this phenomenon. Number 1. Explaining the phenomenon. To understand why people perceive a distinction between the Pacific and Atlantic Oceans, we need to consider surface appearances and what occurs beneath the surface. According to Sally Warner, a professor and physical oceanographer at Brandeis University, it's essential to differentiate between what happens at the surface and what transpires below. Number 2. The role of ocean fronts. Ocean fronts, characterized by differences in temperature or salinity, can create visible lines in the surface water. These fronts can be sharp and come together in a manner reminiscent of different flavors of ice cream in a carton. While these distinctions are more apparent near the coastlines and river mouths, they also exist in the open ocean. Number 3. The effect of rivers and glaciers. When rivers flow into the ocean, they bring fresh water that contrasts sharply with the surrounding seawater. River water is often silty and has a distinct color, creating a visible separation. Moreover, fresh water is less dense than saltwater, further contributing to the differentiation. However, given enough time, these waters will eventually mix completely. Number 4. Mixing speeds in different locations. The Pacific and Atlantic Oceans mix at varying speeds depending on the location. For instance, near the southern tip of South America, where the continent disperses into smaller islands, the mixing is relatively slow. The Strait of Magellan, along with the Beagle Channel, showcases the interaction between freshwater from melting glaciers and saltwater, resulting in visible lines. Number 5. The influence of climate change. It's important to acknowledge the potential impact of climate change on the mixing speeds between the Pacific and Atlantic Oceans. The alteration of wind patterns and the intensification of waves can accelerate the mixing process. Scientists are actively studying these changes to gain a comprehensive understanding of their implications. Number 6. Ocean currents and exchange of water. While the Pacific and Atlantic Oceans mix at different speeds, they constantly exchange water due to global currents. These currents facilitate the movement of water masses between the two oceans, contributing to the overall mixing process. It's crucial to note that the mixing of water doesn't necessarily imply a transformation of its properties. Number 7. The meeting point, Cape Horn. The Pacific and Atlantic Oceans meet at Cape Horn, located at the southernmost tip of Chile in South America. The strong current in this region carries water from the Pacific into the Atlantic. Historically, this treacherous route was the only passage between the two oceans before the construction of the Panama Canal. Number 8. Debunking the viral videos. Viral videos showcasing a clear boundary between the Pacific and Atlantic Oceans often feature the Gulf of Alaska. However, these videos are misleading. The color contrast is not indicative of the two oceans remaining separate. Rather, it results from the meeting of sediment-rich freshwater from melted glaciers and saltwater. Over time, currents and eddies cause these waters to mix. In conclusion, the claim that the Pacific and Atlantic Oceans don't mix is a misconception. While visible boundaries and differences in color may exist in certain areas, these distinctions are temporary, and the waters do mix over time. Understanding the science behind oceanic interactions enhances our appreciation for the dynamic nature of our planet's water bodies. Here are some simple questions and their answers in short for you. Number 1. Can you see a clear line between the Pacific and Atlantic Oceans? There may be visible lines in certain regions due to differences in temperature, salinity, or the influx of freshwater, but these lines are not permanent, and the waters do mix. Number 2. What is the meeting point between the Pacific and Atlantic Oceans? The Pacific and Atlantic Oceans meet at Cape Horn, located at the southernmost tip of Chile in South America. Number 3. Do ocean currents play a role in the mixing of the Pacific and Atlantic Oceans? Yes, ocean currents facilitate the exchange of water between the Pacific and Atlantic Oceans, contributing to the overall mixing process. Number 4. Are the Pacific and Atlantic Oceans influenced by climate change? Climate change can potentially impact the mixing speeds between the two oceans, altering wind patterns and wave intensities. Number 5. Do viral videos showcasing clear boundaries between the two oceans reflect reality? No, these videos often misinterpret color contrasts resulting from the meeting of freshwater and saltwater, leading to a misconception that the oceans don't mix. I hope you have enjoyed our video, so don't forget to hit that subscribe button and turn on notifications so you never miss a fascinating science update. Thanks for watching, and stay tuned for more amazing discoveries.